You've probably heard the term stunting a lot in discussions about global health. But how is it actually measured? Well, it's not a guess. It's a really precise science. So today, we're going to pull back the curtain on that process and show you exactly how health professionals get that accurate measurement. Let's get into it. Okay, first things first. Before you can measure something, you've got to know exactly what you're looking for. So what does stunting really mean from a clinical point of view? It's way more than just being short. It's a specific medical classification that has a very clear definition. So to get to the bottom of it all, here is our roadmap. We're going to start with what a stunting score actually is. Then we'll look at the global standard everyone uses for comparison. After that, we'll dive into the nitty-gritty of how to measure a child correctly, see how that physical measurement turns into a meaningful score, and then we'll wrap it all up with why every single one of these details is so incredibly important. All right, let's jump right into our first section. To measure stunting accurately, we have to go beyond just the word itself and look at the very specific indicator that scientists and doctors rely on. And here it is, the height for age Z-score, or HAES for short. Now, this isn't just a measurement in centimeters or inches. It's a comparative score. Basically, it tells us how a child's height stacks up against the World Health Organization's global standard for a healthy child of the exact same age and the exact same sex. So that brings us right to our second point, the WHO growth standard. You can think of this as the universal rulebook, It's the official benchmark that makes sure we're making fair and consistent comparisons of kids' growth, no matter where they are in the world. So what are we actually comparing against? Well, this standard isn't just some random number. It's based on the median height from a huge population of healthy children. And median just means the exact middle, the 50th percentile. So we're literally comparing one child to the precise midpoint of what's considered healthy growth. Now, to really get this comparison, we need to know about something called standard deviation, or SD. Don't worry, it sounds more complicated than it is. A standard deviation is just a fixed unit of measurement. It tells us how far away a child's height is from that median, that middle value. It's kind of like measuring distance in steps instead of feet. And this is the crucial part, the magic number. A child is officially classified as stunted if their height for age Z-score is below -2 standard deviations from that median. That means their height is significantly lower than the average for healthy kids. It's not a subjective opinion. It's a clear, data-driven line. And the scale goes even further. If a child's score drops below -3 standard deviations, they're then classified as severely stunted. This is a really important distinction because it helps prioritize who needs the most urgent care and helps us understand the scale of a nutritional problem in a community. Of course, all these scores and thresholds are completely meaningless without one thing, an accurate measurement to begin with. So, for our next section, let's get practical. Think of this as a field guide for getting that data right. Right off the bat, you can't just measure every child the same way. The technique actually changes depending on how old they are. For babies and toddlers up to 23 months old, or really any kid who can't stand up straight and steady, you measure them lying down. This is called recumbent length. For kids 24 months and older, you measure them standing up. We call that standing height. And when I say this is precise, I mean it's really precise. To measure a baby's length, you need a special measuring board called an infantometer. The child's head has to be touching the fixed part, their legs have to be gently straightened out, and their feet need to be flat against the sliding foot piece. And you record this down to the nearest tenth of a centimeter. It's so exact that it's often a two-person job, and they'll even take the measurement a couple of times to be sure. For older kids, the process is just as meticulous. They use a device called a stadiometer. The child has to stand up straight with no shoes on, and check out this posture. Their heels, their butt, and their shoulder blades all have to be touching the vertical board. Then the headpiece is gently lowered down, so it just rests on the very top, the crown, of their head. And the level of detail here is just amazing. The WHO has a protocol for pretty much any situation you can imagine. For example, let's say a child under 2 is measured standing up for some reason, which isn't the normal procedure. Well, you have to add exactly 0.7 centimeters to their measurement. This converts it to what their lengths would have been, making sure the data stays consistent. Okay, so we have our super precise measurement in centimeters. How do we turn that number into that meaningful height for age Z-score we've been talking about? Let's connect those dots. Now, this might look like a scary math formula, but the idea behind it is actually pretty straightforward. You take the child's measurement, you subtract the median height for their specific age and sex, and then you divide that difference by the standard deviation.
The result is the z-score. It's a direct calculation of how many of those standard deviation steps the child is from that healthy middle point.
Now, you might be relieved to hear that health workers aren't usually doing this math by hand out in the field. To make sure everything is perfectly accurate and to avoid any simple calculation mistakes, they use specialized software from the WHO, like WHO Anthro. This tool calculates the precise z-score for them automatically. This table does a great job of pulling everything we've talked about together. For kids under 2, you measure their length lying down. From 2 to 5, it's their height standing up. For both of those groups, you use the WHO Child Growth Standards, and that key stunting threshold is a score below -2 standard deviations. The process is pretty similar for older kids and teens, but it just uses a slightly different reference data set from 2007. So we've walked through the definitions, the standards, and all the procedures. For a final section, let's just zoom out and really understand why every single one of these details is so unbelievably important. Really, the key takeaway is this: precision is everything. For an individual kid, getting an accurate measurement means getting a correct diagnosis, which means they get the help they need. But on a much larger scale, this reliable data is what allows governments and organizations to design public health programs that actually work. And it all comes down to using the right equipment and following the right procedure every single time. Understanding how to measure stunting correctly is the foundation. It's the absolute first step in a much longer journey. But it leaves us with one last, important question. Once we have this accurate data, what comes next? Because that's the moment when measurement turns into action. Thanks for watching.